Good morning, everyone. I am Mansi Magar, Assistant Professor from GMD College, Senior, Nashik. Now, I have studied about the soil chemistry, lecture 7 from agriculture chemistry. Hope so. We remember last lecture. In the last lecture, we focused on soil, atmosphere, soil, water, soil, microorganism, or biological system of the soil. Physical property of soil. We also see the three characteristics of the soil, like soil color, soil texture, and soil density. Now, in today's lecture, remaining characteristics of the soil. The fourth characteristics of the soil is soil structure. When a soil particles aggregate, they form clumps of the soil that are called beds. Their shape and arrangement determine the soil structure. The most paired arrange from less than 1.5 to 15 centimeter in the diameter. Sorry. The ability of bed and soil particles to stick together and hold their shape is called as consistency. Some soils have no definite structure. The most soils contain two or more kinds of structure. In some such as soils, the beds lack a definite shape or arrangement. The next point is the soil structures are divided into six types. First is plate-like soil structure, second prism-like soil structure, third block-like soil structure, fourth spheroidal, fifth single grain or sixth massive soil structure. In six soil structure, three are subdivided. First, prism-like soil structure divided into two types. First is columnar soil structure. Second is prismatic soil structure. Next is block-like soil structure, also divided into two parts. First is angular blocky soil structure. Second is subangular blocky soil structure. Spheroidal also divided into two types. First is granular, second is crumb-like soil structure. When soil particles aggregate, they form clumps of soil called as beds. The importance of soil structure. It helps in determining the relationship that exists between soil, water and plants. Second, it controls amount of water and air in the soil and also their circulation and momentum. The fifth characteristic is porosity of soil. The percentage of porosity of soil is determined. The formula is 100 minus apparent specific gravity upon absolute specific gravity into 100. It gives an idea of the total pore space present in the soil. It is responsible for better plant growth because they contain enough air and moisture. The sixth characteristic is soil temperature. It is the important characteristic of the soil because it's important for plant growth, stability of nutrients, microbial growth, and also rate of different reactions. The factor affecting soil temperature is nature of soil, moisture, plant cover, topography, climate, and season. The first is nature of soil. A dark colored soil absorbs more heat than light colored soil because dark or black colored soil contain more humus. Soil texture affects soil temperature by controlling pore space. Next is soil moisture. Moist soil have high specific heat than dry one. Next is plant cover. It acts as an insulating material and reduces in temperature variation. Next is topography. The angle at which some radiation fall on the earth greatly affect the amount of radiation received per unit area. Next, climate. The region when rainfall is high, their soil temperature is lower. Next is season. The soil temperature varies with different season of the layer. The next point is surface soil and subsoil. The surface soil is the soil through which implement move during cultivation. It is more loose, more dark or black than subsoil. Subsoil is the layer below surface extending down to the parent material. The function of soil. The soil performs three functions: chemical, physical and biological. In physical function, the soil acts as mechanical support. Soil acts as a receiver of the water and air. The next is chemical function. Chemically, soil is a storehouse of the nutrients. That means it contains large number of organic and inorganic compounds. Example: sodium, calcium, potassium, sulfur, oxygen, nitrogen, etc. Next function is biological function. The soil is an habitat of very large number of organisms like worms, insects, fungi, bacteria, etc. They decompose dead plants and animals and convert the complex compound like protein, cellulose, etc. into simple substance like nitrate, carbon dioxide, etc. The next is chemical property of the soil. First is soil reaction. Three types of soil reaction: acidic, alkaline and normal. Soil having pH range of 6 to 8, 8.5 pH. The importance of soil reaction: it influences crop growth both directly and indirectly. It is also influence of soil structure. The need of fertilizer depends on the soil, affect the physical condition of the soil. The soil solution. In soil solution, mixture of the soil moisture with the solid and gases is called as soil solution. It is of two types. First is inner soil solution. It is a mixture of fine particles and moisture. Next type is outer soil solution. It is the liquid in the large capillary spaces having different concentration than solute particles. The main function of soil: supply mineral nutrients to the growing plant. Soil fertility depends upon the calcium plus and sodium plus iron. Next point is factor controlling soil reaction. First, nature. Next, concentration, type of colloidal material, parent material, climate, culture, particles, nature of exchangeable cation, and last one is soil or water ratio. The first one is nature of colloidals. The adsorbed cations which surround the metal dissociate in the soil solution. Due to the concentration and nature of dissociated cation, pH of the solution is affected. Sodium methyl first plus water molecule, it gives sodium plus OH minus and H minus methyl. Next one is soil solution. The soil solution carries a number of salts dissolved in the capillary water. Increases in acidity depends on the concentration of salt and valency of the electrolyte cation added to the soil solution. The soil reaction also influenced by the presence of CO2 in the soil and air. Next is climate and parent material. The soil reaction depends on the rainfall and temperature of the region soil forms. The high rainfall is acidic in nature while those of low rainfall are alkaline. Soil reaction depends on the rainfall and temperature of the region. The soil formed in high rainfall is acidic in nature, while those of low rainfall are alkaline. The soil reaction is independent on parent material from which soil is formed. Next is soil acidic and buffer action. The H plus ion present in the diffuse layer consist, sorry, constitute called as reserve acidity, while those parent in the soil solution give rise active acidity. The resistance offered by the colloidal particles to the change in the reaction called as buffer reaction. Importance of buffer action. First is it stabilizes the pH of soil, keep the availability of plant nutrients. The next is regulate the activity of the soil influenced by the soil reaction. Next one is ion exchange method. Ion exchange method, the complex colloidal has tendency to change the ion when it comes in the contact with the electrolyte called as ion exchange. Both cations and anions take part in the exchange. First one is cation exchange or base exchange. When an ordinary soil is brought in the contact with an electrolyte solution like KCl, a part of potassium is adsorbed by the soil and an equivalent quantity of cation adsorbed by the soil colloid is liberated. During the process, equivalent quantity of cation exchange and reaction is localized at the surface of the colloidal particles called as cation exchange. Example is this is the diagram for ion exchange. If sodium is exchanged with K in presence of 2 mole of KCl. This is the diagram for ion exchange. In anion exchange, it is similar to cation exchange. Anions such as sulfate, carbonate, bicarbonate, phosphate are exchanged from the solution. It has importance in relationship to phosphate ion and their fixation. OH clay plus H2PO4 minus it gives H2PO4 clay plus OH minus. This is the ion exchange example. This is the ion exchange example. Thank you.